एमटीपी आणलाय
तो बुलाना पड़ेगा
स्वागत सर सबको बुला दीजिए
बुलाओगे
इंगोले सर समोर या
बोलूंगे ना बोलूंगे सर
मलिक मॅडम तुमच्या फोटोमध्ये घेऊन जा आम्ही काढता अटल डीपी K.D.K FDP आहे का Very good morning to all the participants. I welcome you all for the first session of day 2 of this 1 week MDP Atal MDP. Today we have a session of Dr. P.M. Purchumdi, sir, Professor, Department of EC, VNIT Nagpur. The topic of today's presentation is Deep Learning Concept and its Application. Sir is having a very vast experience in his field. Sir has delivered more than 200 faculty development expert lecture in a faculty development program. And sir has received around 2 crore grants in his college. I request sir, I request Khandai sir to welcome Purchumdi sir with a sapling and memento as a token of respect and gratitude. Sir, please.
So you start with deep concepts in deep learning. This in my bag there is a pointer.
Sir, you need to wear this also.
The dongle you have to connect to that.
Okay. हे डोंगरी मला सरांचं लक्षात अच्छा ठीक आहे दिस यू नीड टू वेअर ॲक्च्युअली people may have some questions also actually. Other people may have some questions. They'll ask a few questions so that you take it.
Okay, so this for me.
Yes, sir.
Am I audible? So when are we going to ask question now?
Anytime.
Okay.
During this session, na, they'll
Huh?
ask a few questions. Na?
No. They'll ask questions to us.
Okay.
So then why should I wear this? Huh? अच्छा अच्छा गरज नहीं. This makes you uncomfortable. So, dear friends, as you already know, the topic of today's discussion that is related to deep learning and its applications. Uh, Initially, I will start with the very basic concept about learning. Why at all learning, and what is meant by learning? Many of us, we already know this particular term, learning, is behind us right from we were at the age of 4 years, 5 years, first standard, isn't it? Many of us were bashed by our parents to send us to school and so on. Okay, so the basic thing behind learning is that, can you tell me what is the basic thing behind learning? Training means what? लर्निंग जो है उसके पीछे का एक बेसिक कंसेप्ट है, कोई माने या ना माने, आजकल लोग जो है बहुत बड़ी बड़ी बातें करके ये करते हैं, लेकिन लर्निंग के पीछे एक बेसिक कंसेप्ट है, वो है फोर्सफुल. न्यूरल नेटवर्क भी आपको अगर ट्रेन करना है तो वो इजीली ट्रेन नहीं होता है, आपको उसको पहली बार करना पड़ता है, दूसरी बार करना पड़ता है, तीसरी बार करना पड़ता है. वेदर इट लाइक्स और नॉट, दैट इज डिफरेंट थिंग. वी ऑलरेडी नो, मीन्स एटलीस्ट मैं तो कभी खुशी से स्कूल नहीं गया, पेरेंट्स ने अच्छे से बजाया, स्कूल में भेजा, तब स्कूल में गए. इवन नाउ हम जब बच्चों को पढ़ाते हैं तो वो क्या खुशी से पढ़ते हैं? पढ़ने के लिए यहाँ आए हैं? नो, दे केम हियर फॉर जॉब, दे केम हियर फॉर जॉब्स. इज एज सिंपल एज दैट. अभी हम उसको बहुत अलग तरीके से, आजकल स्टाइल जरा थोड़ी चेंज हो गई है तो आड़ा टेढ़ा घुमा फिरा के बोलते हैं, बट बेसिक थिंग बिहाइंड लर्निंग इज इट हैज टू बी रिपीटेटिव. Many times there is no reason why it is like that. When we were told that this is 0 and this is 1, this is A and this is B, was there any reason why this is A? No, this is A means this is A and this is B means this is B. As simple as that. Okay. So in this machine learning also, we have to follow some basic paradigms. We provide a pattern and tell the machine that this is this. That's all. So in deep learning also, just like in our other things, real life things, many times we follow the paradigm. ये क्यों करना है, इसका many times कोई reason नहीं होता. There is no reason why we should do a particular thing. Just it has been historically proven that this is good. That's why we keep on doing that. Fine. Similarly, in learning also, many times there are no reasons why we are doing that. But that is already a proven paradigm. That's why we do it. Fine. So, in real life, as you already know, okay. So this is organization of the talk. After that, we will proceed to the talk. First, black bullets, learning, knowledge, information, data labels to nonlinear classification. These are the very basic fundamental concepts of learning. Fine. Some of the specific topics like SVM that I will drop for the time being. I think I had already removed from this particular presentation. Then again we will start from perception. As far as this lecture is concerned, I want to keep it around the concept of neural networks. SVM is a statistical, classifier. So that I want to keep aside because in itself SVM is a big topic. But just in one or two sentences, I'll tell you the concept. Then different kind of neural networks are there. After that, when you have this neural network, how do you apply that neural network to the real life applications? Okay, those steps they start in those yellow bullets. Feature detection to, everything. Further steps are there. So let us start with learning. Flow will be going like this. First, we will discuss about deep learning. What are the basic fundamental blocks, uh, concepts of programming it, and then at the end, I will explain one or two applications. I think here we are concentrating only on number plate recognition, no? Yeah, I have 2-3 applications which my PhD students are working on. I was in fact asked to give demonstration here, execution, but the problem is that that requires machines minimum to minimum with 30 GB RAM, and then setting up that atmosphere, it requires a lot of time. You have to set up many directories, many databases, this, that, and the databases are to the tune of 30 GB, 40 GB, up to 100 GB. So setting up that machine itself, one machine setup requires 3 days. So until and unless it is everything is already set up, it is not possible to give such demonstrations here. We do it in our Center for Artificial Intelligence. We have set up one Center for Artificial Intelligence. There we can do it. So coming to the basic concept, what is learning? हम बच्चों को बताते हैं कि you have to learn this. Means what? Our basic concept is students should memorize it. At the first level, we consider that as learning. But then that is not learning. Then what is learning? Learning is abstraction. Whenever the student learns, he might have learned for one full semester or for one full year. He should be able to tell in short. And when I talk about in short, there will be a question in how much short. That will be at different levels. Okay, isn't it? You can have full 900 page book. For one subject, you may study around 300 pages out of that. Out of those 300 pages, so at MTech level, different level of depth of studying will be there. At BTech level, there will be different depth of study. Many of you might have done your 10th, 11th or 11th, 12th with electronics, what do you call it, vocational. There the level or depth is different. Okay. Now, this particular word abstract, we use it very casually, summary or abstract. But there is a lot of philosophy behind that word. And the beauty of that word is that that decides whether you have understood a topic or not. If you can abstract at different level, that means that you have understood this. Otherwise, if you are doing it like that in its own way, it means you have only learnt it by heart or mugged it up. Okay, so the word abstract is very important. Okay, now you have learned something, you are able to abstract that knowledge. Okay, now what is the next thing? Next thing is that application. If you have learned something and if you are not able to apply it to real life applications, that means you have not learned it. It is as simple as that. When it comes to learning, these two steps are very important. Whatever you do, you study a fuzzy system, you study a neural network based system, the first step is it should learn the task. After the training, it should learn the task. And the second thing is, after learning the task, after learning the task, it it should be able to solve another problem. If it is not doing it, it means you have not learned it. Okay, unfortunately in our education system this is missing. What we do is we teach a subject a particular syllabus. Okay, students also say that we have learned it, but we ask them to solve a problem. Okay, they are unable to solve it. For example, I teach microprocessor. I tell them to interface say a stepper motor with this port, rotating left, right, whatsoever. They are able to do it. Okay, but then when I tell them to have the same problem, to apply the same thing to an industrial stirrer, everybody knows stirrer. आपण मराठीमध्ये ज्याला वरण घुसळायची रवी म्हणतो, isn't it? If I ask them to implement that, they do not know how to do it. I have to tell them that you have to use motor, you have to use this, you have to use that. They should be able to understand that for solving this problem, I have to use stepper motor. Then how is stirrer? One or two clock cycles clockwise, one or two clock cycles anti-clockwise. That student should be able to understand. Unfortunately, this component is missing in our education system. You have to tell them specifically, they will do it. In short, why this is happening? This is happening because without application of brain, they are only following whatever is taught in the board. I handle a subject, statistical signal analysis. It is a mathematical subject for MTech students. In my MTech first class, I tell them, whatever you are going to study, it is mathematics. Without mathematics, there is no engineering. First thing. Second thing is, whatever I am giving you as notes, whatever I am teaching you on board, out of that, there won't be a single thing in your question paper. Whatever I am teaching you, you learn the technique, you learn the gist, you learn the abstract of that. The question paper will be such that you will have to apply that in your question paper to solve it. That is what is learning. Unfortunately, even myself, we learned out of that old system. I am no different than you people. Okay, we learned in that system, but gradually we have to now transform. Fine. So when I talk about, we have already talked about abstraction and application of knowledge. Knowledge is represented by information. What is knowledge? I give you a book. Is the knowledge in that book? No. There is text, and that text is representing what? Information. It is only an information. Until and unless you learn the text, you interpret it, you come out with different meanings. You come out with different meanings, what it means, what is written in the book. That is what is knowledge. And then how can you extend it to real life applications? That is what is knowledge. Whatever is written in the book, that is not knowledge. Then where does the knowledge lie in that book? In that book, what we have? We have statements, sentences. Every sentences have got some words. Words are nothing but labels. Every word has got some meaning, it carries some meaning. It may have numbers and it may have mixed data. Labels and numbers, everybody is, but mixed data means what? You have course code ECL 405. You have subject number like this. Subject code in your syllabus you might be having like this, ECL 405. Now ECL 405 is a number of that particular subject, ECL is label, 405 is number. It may indicate 4 means fourth semester, 05 means fifth subject. Okay, and ECL will indicate electronics and communication, L means laboratory, might be like that. Okay, so this is a mixed label. So where does this information lie? Information lies in these labels, numbers or mixed data. Does this information means knowledge? No, information doesn't mean knowledge. What is the relation of ECL with 405? That is the knowledge. So knowledge lies between in the relation between the data elements. And what that data can be? That data can be labels, numbers or mixed data. Unfortunately, computers understands only numbers. Unfortunately, computers understand only numbers. They do not understand ABCD. Then how do we solve this problem? We solve this problem by converting those numbers into labels into numbers. It doesn't understand ABCD. And how do we do that? There is something called as ASCII code, American Standard Code for Information Interchange, isn't it? So what does that do? It can convert all these non-numerical things into numerical things. Once you convert them in numerical things, then your computers can interpret it. Then you can implement. I think many of you are from computer science background, and it is a big field, that is natural language processing. That whole natural language processing, it runs on this conversion. Otherwise, digital computers, machines like this, they cannot understand labels or text. You have to convert them into numbers, and then those numbers are understood by your computers. So what is meant by abstraction then? Again, coming back to abstraction. Now, see, we are going it very logically. First, what is abstraction? Brief introduction to abstraction. Then, application of that learned knowledge to the real life systems. Then, how is that knowledge represented? Knowledge is represented using information. What does the information contain? It contains labels, numbers, or mixed data. Then, coming back to abstraction, why to have abstraction? That is again an interesting issue. Because whatever lies in front of our eyes, it is not, everything is not important. What is important for you, it may depend upon person to person also. You read the same book, one student gets 90 marks, another student fails. Okay, so everybody's capacity to extract information, extract knowledge from the information is different. Okay, whatever you extract, that is what is called knowledge. Okay, and this knowledge can be at different level. As I have already told you, we also read Mahabharata and Gita, this, that. Okay, but we remember only 4-5 things out of that Mahabharata and Gita. Some religious priest, he may study that Mahabharata and Gita, and he may be able to tell you hundreds of stories from that, and even the gist of the story. Fine. So anyway, so what does abstraction contain and what it requires? See here, abstraction involves, first thing is acquisition. Acquisition means what? Acquiring something, acquiring data. I have got a book. To understand what is written in the book, I have to first read it. Okay, that is what is called acquisition. This term is very common term for I think even for computer science engineer, but for electronics engineer this is very common. We use data acquisition system. There is some instrumentation measuring say temperature, and we measure output of ADC, acquire data. What does that data contain, whether the temperature is 30 or 50, that we will understand afterward. But the first thing is, whatever is data that you have to take, that is what is acquisition. Then you have analysis. You have to then take the decision. In a factory, you may have to take the decision that if temperature is beyond 500 degrees, close down the heater. If it is below say 300 degrees, turn on the heater. So you have to first understand what does that data contain. That is what is analysis. Then there can be estimations. Estimations means what? Whatever is the data available, whatever is the history available, I may say whatever is the knowledge available even. Okay? What happened? I'm not doing anything. Whatever is the knowledge available, on the basis of that, you have to approximately estimate something. Parents might have asked you, how much percentage you are going to get in your 10th? This is a common question I remember from my life, that after returning from the examination, हम भी अपने बच्चों को पूछते हैं. Many of you might be having children going to schools or colleges. आने के बाद हम पहला क्वेश्चन क्या रहता है हमारा, पेपर कैसे गया, और दूसरा क्वेश्चन रहता है कितने मार्क्स मिलेंगे. Now think what his brain is doing. Okay, a child in the history who has got 50 up to 50-60%, he will never tell you that I am going to get 90%, even if his paper is good, because he knows the history that मैं अभी तक कभी 60 क्रॉस नहीं किया हूँ, पेपर अच्छा भी गया है तो पापा को बताना कि 90 मार्क्स मिलेंगे बहुत रिस्की है. 90 मार्क बताए और अगर 60 मिल गए तो फिर अलग रिजल्ट हो सकता है ना. और 60 बताए और 80 मिल गए या 70 भी मिल गए तो चलो बेटर है. Fine. So these are all estimations, and we are doing it, I mean, in our daily walk of life, time to time, not time to time, instant to instant. Right, in the morning you wake up and see where is your toothbrush. Your brain has to identify this is toothbrush, isn't it? This is toothpaste. Otherwise you will start brushing with your shaving cream. That happens many times. Okay, so all these things, they come under estimations and detections. Trained evaluations. In the month of December we start thinking in Nagpur abhi thandi to badhegi. It is on the basis of history. That is trained evaluation. Abhi temperature jo hai badhega. Sorry, kam hoga. In the month of March or April we start thinking it will rise up, and then we approximately know also every year that in Nagpur 49-50 degrees is not a very big thing. If you stand below the metro bridge, it may even go to 53-54 degrees. On the basis of our experience, we can have these estimates. Then after trend evaluation, there is trend analysis. You have got trend increasing or decreasing. Then by how much? Our result last time was this much. This time it is greater. Last year it was 80%. This year it is 90%. Okay. So how much is the rise? 90%. Then we analyze why this time the result is more. Was the paper easy, or has the teacher taken additional effort? Has he solved more problems? We do such kind of analysis, and if it is positive, then we tend to repeat it, because everybody wants better results. Fine. Then there is pattern analysis. Whatever you see from morning to night and throughout your life, everything is pattern. We identify, this is my brother, this is my sister, father, mother, whatever, this is my vehicle, and so on. So your brain perceives everything as a pattern. It might be two-dimensional pattern, it might be one-dimensional pattern, it might be three-dimensional pattern, it might be n-dimensional pattern. Okay, so whatever you acquire from your eyes, it is 2D or 3D pattern. Whatever you acquire from your ears, that is one-dimensional pattern. Music is a one-dimensional signal. Picture is a two-dimensional signal. Video can be a three-dimensional because there is temporal dimension. And when it is real life can be n-dimensional. Okay, multiple dimensions can be there. We'll be coming later on to what is exactly meant by dimension. Then after pattern analysis, we detect it, whether it is 500 rupees note or 2000 rupees note. Fine. Then there is matching. We see a face and remember that I have seen this person at this place. That is what is pattern matching. Recognition. You recognize the person with name. That is recognition. Many times we remember the person, but we do not remember the name. So that is partial recognition. That is partial recognition. Then there is analysis. Analysis means what? I am seeing photograph of my brother or sister, and then I think that, oh, she appears to be sad. हम बोलते हैं ना, फोटो में, फोटोग्राफ में या वीडियो में, he is appearing happy or he is appearing sad. That is what is analysis of the pattern. And also synthesis. Synthesis means what? implementation, reproduction of the pattern. We listen to a song and try to sing it. That is what is synthesis. We see a particular thing and try to paint it. That is what is synthesis. Why I am doing this now is that deep learning to a great level, it can implement all those things. Earlier neural networks, they were not capable of implementing all those things to a great accuracy, but now deep learning can do these things with great accuracy. Okay, all these things, all these patterns. Then what is learning now? So application of learned knowledge to real life problems is the final outcome of the learning process. If our students, or even if we are unable to apply whatever we learn to real life applications, if we are not able to do that, we might be claiming that we have learned it. The fact of the matter is that we have not learned it. Fine. The same thing is applicable to machines. Okay. Then what is this? This is last line is very important. Both involve forced. कोई भी ह्यूमन बीइंग हो या न्यूरल नेटवर्क हो, अपनी इच्छा से पढ़ेगा नहीं, आपको फोर्स करना पड़ेगा उसको. ह्यूमंस के फोर्स करने के तरीके अलग अलग होते हैं. ऑल वी हैव लर्न फ्रॉम आवर पेरेंट्स. ओके, नाउअडेज द पैराडाइम हैज चेंज्ड. अभी किसी को मारना वगैरह जो है बच्चे को अलाउड नहीं है. नहीं तो पहले तो हमारा कहावत ही थी कि छड़ी लागे छमछम विद्या एक हम. Now the paradigm has changed, but still some kind of force is definitely. Nowadays they are indirectly forcing it. If you do not learn this, if you do not get this much percentage, then you won't get admission. So that is also a kind of force. Then repetitive. This is A or this is 1 or this is 2. We have been told by our teacher 100 times, and then we have learned that this is A and this is. So repetitive. Then input of data. Force and repetitive input of data. Data was again and again provided to you. Efforts also were there. Efforts in terms of what? 100 times we have to pay attention to what teacher is saying. That is what is efforts. Correction of data. Many times you might have learned. Small children, they tend to get confused between small case b and small case d, or p, small case p and small case q. 9 seeing from one side is 6 seeing from other side. All these things, they will create confusion. So you will have to tell them again and again, this is not b, this is d, or this is d, this is not b. And if a student commits mistake, then what teachers do? They correct those. Many times we study a subject in wrong direction, we fail, then some teacher or some friend comes to us and tells you that don't study it in this way, you study it in this way. That is what is correction of efforts. Correction of efforts. Correction of data भी हो सकता है. Data times you get wrong inputs. Okay, students are told अभी 12th हो गया है, हमारे यहाँ पे वो typically बहुत ज़्यादा problem है in NITs and IITs. You have entered now NIT and IIT, life is settled, so don't worry now, you just enjoy your life. And then when the child passes out, he gets a pointer of 5, not eligible to appear in the training and placement activities. And then he comes to us and starts asking, sir, no, what should I do? People told me like this, so I didn't study. So now there is no way in front of me. And then we have to consult them and do all those things. So you have to be very cautious on what? Efforts in wrong direction. And there is closed loop output check. Whatever is output, you have to evaluate it, again feed it to input. Okay, and this is an iterative process. We have already studied without negative feedback. Without negative feedback, no life is possible. And this is applicable even from your control systems papers to neural network to fuzzy logic. Okay, everywhere, even in deep learning, artificial intelligence, and everybody of us has experienced it. Okay, आप किसी को अगर चने के झाड़ पे अगर चढ़ाते रहो, गलत तो है, लेकिन जिसको आप चढ़ाते हो ना उसको बहुत अच्छा लगता है, until and unless he falls from there. Okay, Positive, this is positive feedback that you are telling that okay, okay, बहुत अच्छा, बहुत अच्छा, बहुत अच्छा. Negative feedback क्या है? ये तेरी गलती हो गई. Correct it, and this will give better output. Positive output, feel good. Negative output, feel bad, but better output. Fine. So same thing is applicable here also. So in every case, that output is to be checked, and whatever is correction required, that has to be. I do not know whether now this font is visible to you or not. If it is not visible, then you may please occupy the front benches. Now you see here, as I have already said, in machine learning, information takes shape of numerical data. Machines understand only numbers. Fine. So A is not A for them, A is 41. That is ASCII code for A. Then, in case of fuzzy learning systems, information may take shape of labels. Many of you might have studied fuzzy set theory or such kind of subject. And there you say low, medium, moderate, highest. But computer doesn't understand that. You have to use membership functions, and using membership functions, you have to convert all those labels into numbers, give those numbers to computers. Computers will process those numbers. After processing that, it will give that result in terms of numbers only, and you will convert those numbers again to labels understandable to human beings. Okay, that's why you have to have everything in terms of numbers. Now, conventionally, numerical data was pre-processed and applied to learning systems like neural networks. Now, this is very important, pruned or thinned. This is a pre-processing technique. You have a lot of data. Okay, pruning is for what purpose? There is unnecessary data. Remove unnecessary repetitive data. There can be outliers. Okay, don't need pruning means that need to be avoided. Wrong data or unnecessary data that needs to be provided. What is the example of pruned data? Our students tell each other, you did not study that hard. You have entered NIT, no? Need not worry now. देखो बिल गेट्स कहाँ ये हो डिग्री कंप्लीट की थी उसने. He is a billionaire. Okay, he was a failure actually. So he is a billionaire, did not study. Now, is this example applicable? Bill Gates is a failure is fine. This doesn't mean every failure is Bill Gates. Every failure candidate is going to become Bill Gates. It is not that. So such kind of data, you need to prune that data. Fine? It's removing unnecessary data. It has been observed that most of the real life applications are modeled as classifier. This is very, very important statement. You might have studied data science, AI related, artificial intelligence, neural network papers, and everywhere you come across a term called as classifier. Now there is a basic question, why to study this classifier? We have to study the classifier because human life starts from a classifier. As soon as a child takes birth, first thing checked is whether it is a girl or a boy. Classifier, binary classifier. Whether to do something or not to do something, again a classifier. Whether you are pass or fail, again a classifier. All these are binary classifiers. Output is in terms of only two. There can be multi-class classifiers. Multi-class classifiers means what? There might be 7 currency notes, 500 rupees, 700 rupees, whatever, 1000 rupees, 2000 rupees. 7 classes are there. Fine. There can be a regressor. Regressor means what? There can be a large number of classes. What is the percent? Are you going to get 50% or 51% or 51.5%? Number of classes are large. We call such applications as regression or regressor applications. But directly or indirectly, if you see, the whole life is filled with classifiers. So in artificial intelligence, what happens? Everything starts with design of a classifier. Names might be different. Single class classifier, multi-class classifier, interpolator, regressor, and so on. Large number of, names are there. But everything in one form or the other becomes a classifier. That's why we have to study classifiers. Then you might have also heard about intelligent classifiers. Fuzzy systems. Why to study fuzzy logic or neural network? Somebody will tell you that they can give us intelligent classifiers. Let me tell you, whatever you implement using this digital machine, it cannot be intelligent. Then what is intelligent? Intelligent is the mathematics inside it. That's why a person working in hardware, he gets 10,000 salary, and person working in software can get 1 lakh, 2 lakh, 5 lakh, or whatsoever. Okay. So when you talk about intelligent classifier, hardware is not intelligent. How much intelligent program you have written, that is intelligent. A mathematical technique can be intelligent. Algorithms, they are all mathematical techniques. Sooner or later, they reduce to some mathematical techniques. So, intelligent classifier. Now, as I have already told you, classifiers are not intelligent actually. Then what is intelligent? Intelligent is the mathematical formulation or algorithm behind it. On its own, no classifier is brilliant at absolute level. Now, this needs to be little elaborated. If I train a classifier for human face recognition, same classifier I cannot use for recognizing currency notes. The classifier has to be trained for a particular application. And everybody of us, all of us should thank God that the single brain is there for recognizing our friends, relatives, enemies, currency notes, vehicles, this, that, and so on. Okay. In terms of mathematical classifiers, they are not that intelligent. That's why we say that however intelligent this might be, this may become, intelligent due to large memory or some kind of mathematical algorithm on it. But then they cannot compete a human being. So that's why we need not worry about artificial intelligence taking jobs of human beings. The only thing is that machines will do non-intelligent jobs, and humans, whether they like or not, they will have to do intelligent jobs. So better to start doing it right now. Otherwise, if you keep on doing routine tasks with AI, you will be replaced by machines. Okay. So anyway, each human is also brilliant on specific areas. मैंने अभी ऐसे बताया कि ब्रेन जो एक ब्रेन कैन डू मल्टीपल टास्क, बट इज इट लाइक देयर इज नो लिमिटेशन? There is obviously limitation. There is that depends upon training of the brain. Two people of equal IQ, if one takes BTech in electrical engineering and another takes MBBS, after 5 or 10 years, will they be able to do job of each other? No. So human brains, they are also intelligent in specific areas, depending upon in which they are trained. Of course, there were some exceptions. You already know. Jagdish Chandra Bose. Okay, he started his work from biology, but now it is considered that he is father of wireless communication. Okay, many such examples are there, though countable on fingers. Pasteur, we have studied his theorem in physics, but he was the person who invented the first vaccine, antiviral vaccine. Okay, so these people, they were gifted. Their brain was working in multiple areas. But if somebody asks us to solve a problem of mechanical engineering, we won't be able to do it. Anyway, so that is what the last is. Human is also brilliant in specific areas, barring a few exceptions like Pascal, Jesse-Bose, etc. Then next we start to understand what is the basic classifier. I have drawn a line like this. We were in 5th standard told that 2 points are enough to draw a line. What does the line do? If I ask you, ये line करता क्या है? It classifies. The whatever was this is our frame of reference. Okay, and then this line has bisected that. In fact, I will say trisected, not bisected. One region is above the line, another region is below the line, and the third region is line itself, and the line is called as classification boundary. It is neither in region 1 nor in region 2. Okay, it is on the boundary, and in classifier language we call it classifying boundary. Okay, is it that only thing? Is it that only thing? What does it do beyond that? How many points will be there on a line? Only two? Infinite points can be there. How many parameters are required to express a line? Yes, only two. We have already learned the equation mx plus c. These are constants, and y and x, they are variables. Y and x are variables. So on a line, how many points can be there? Infinitely many. Okay, but once you have these two parameters, you need not remember xy coordinates of those infinite lines. So what it has achieved? Infinite points to only two values. What is this? This is data compression, isn't it? Otherwise, on a line, how many points would have been there? Infinitely many. Infinite x coordinate, infinite y coordinates. Okay, and then if I know these two values m and c, with only two values, I can remember all those xy coordinates. So what I have done? I have done data compression, or I will say that it is abstraction, isn't it? There were infinitely many points. I am remembering them using only two. This is nothing but abstraction. Large, instead of large volume, I am now having only two values, and without missing anything, I am able to express all those infinite points. So that is what is abstraction. The only thing is, instead of this format, we will change it to some different format. Another thing is that to calculate this m and c, how many points do you want minimum? Only two. For slope y2 minus y1 divided by x2 minus x1. Once you have this m, take any one point of those two, substitute m there, substitute xy in the equation, you will get c. So using only 2 points, you can represent all infinitely many points lying on that line. This is what is abstraction. And the process which you have carried out in your 5th standard or 6th standard, I do not know when individuals studied it, but the process of calculating this m and c is nothing but learning for this particular application. Many times, okay, beyond that, as I have already told you, this line is dividing in two regions. Now, in many real life problems, the line will not be straight, or I will say classification boundary will not always be straight. The classification boundary might be like this. It might be like this, parabolic. It might be like this, hyperbolic. This and this one class, and remaining portion another class. So the first straight line, that was a linear boundary. Then there can be hyperbolic boundary, parabolic boundary, or any region. Many times it might be available in terms of a polygon also. There might be some hexagon. Whatever is inside this is class 1. Whatever is outside is class 2. Now, if you think in that perspective, whatever we have been studying, every shape is a classifier. Is it or not? Inside the shape, outside the, and the shape itself. So 3 classes, out of which the shape itself is the classification boundary. Instead of hexagon, there can be a circle, there can be octagon, anything. And how do we take a decision whether the point lies inside the shape or outside the shape? Everybody knows equation of a circle. Equation of a circle: x square y r square. X square plus y square is equal to r square. Now suppose I have got this r square. I will write suppose 25 and 5 7. Point is 5 7 xy. Whether this lies inside the circle or outside the circle. What do we do? Simply we substitute this xy here. If it is matching, left right side is matching, then we say that this point will lie on the circle. 5 7 both are positive, so it has to be somewhere here. If this is matching, then we say that this is lying on the circle, lying on the classifying boundary. Now suppose after substitution I get, if I add this, what will happen? X square is 5 square 25 plus 49, so it is 84. 74. 74. So this side is giving me 74, this side is giving me 25, not lying on the circle. Obviously, where will it lie? It will lie outside, somewhere here. So if I have such coordinates of a particular entity, I can decide whether it is in class 2, outside the, suppose it is class 2, inside the circle, it is class 1 say, and the boundary itself. If equation is satisfied on the boundary, if this is greater than the constant value, not satisfied, but outside. If it is less than this, not satisfied, but inside. So, suppose I have learned a particular system, might be equation of line or might be equation of the circle, and an additional data point is given, I can decide whether it is in class 1 or class 2 or on classifying boundary. Okay. Calculation of parameters of the shape, whether circle or line, that is learning for this particular system. Is it clear? So what is the first step? First step is data will be given to you. From that data you will have to calculate parameters, that is learning. After you have learned the system, means you have calculated the parameter. Suppose you have calculated m and c, you can write equation of the line. After writing of the line, what is the next task? Next task is to check whether a given point is in class 1 or class 2 or on the classification. This basic principle we are going to study everywhere now. So same thing is being said here. Now how to, what can be application of this? X, Y ये सब हम बात कर रहे हैं, ठीक है, isn't it? But then what is application of this? For that, is there any person on the computer? You have to switch between. Don't close this. Just come out of this. Minimize it. You can minimize it. Escape. Okay. And then open. There will be that. Okay. Another presentation is convolution and deconvolution. Please come to this. This one. Now, what are these x and y? So far we have studied it. Go to next. Come to this one. Fifth slide. This one. Okay. I have got say 10 students of my class. What happened? You can click this one. This one. I have got 10 students of my class. Okay. And I know suppose their height first. H. I plot H on y-axis, and then their names A, B, C, D, E, F, G on x-axis. Okay, like this. As you can imagine, this can be a bar graph. Okay, representing height of the students. Now, in general, we know, isn't it? Girls usually have less height, boys comparatively have better height. There can be exceptions. If there are exceptions, then this system won't be applicable. For the time being, let us believe that there is no such case. So you can see here, A has got some 5 feet 8 inch height, and all boys they have height above 5 feet 8 inches up to 6 feet. Fine. Then girls have heights like this. F has got height 5 feet 5 inches. G has got height 5.2 inches feet. H has got height say some 5 feet 1 inches, and so on. Now this I have plotted. Okay. Now without looking at the person, only looking at this graph, I want to classify only on the basis of height, who is girl and who is boy. And I have given additional information that there is no exception to the rule. Boys have got higher height, all girls have got lower height. So what I can do, even if I do not draw these lines, okay, I can see this is a group of boys, this is a group of girls. Easily I can say everybody below, before E is a boy, after E all these F, G, H, I, J, they are all girls by observation. How do I do it mathematically? For doing it mathematically, I will have to find out a line between these two groups, so that all boys they are on one side of the line, all girls they are on other side of the line. Fine. So given these two groups, group one of boys, another group of girls, if I can find out this line, equation of the line, I will be able to classify, because once I get the equation of the line, I know this individual this thing. Okay, I know individual these values. After finding out equation of the line, if I substitute this coordinate, I will get whether it is a boy or whether it is a girl using this theory again. Okay. Now, the process of finding out equation of this line is nothing but learning. The process of finding out equation of this line is nothing but learning. Now, what I do is, instead of height only, I take another parameter, that is weight. So height on x, name on, this graph is for weight only. So on x-axis names, on y-axis weight, might be 45 to 100. Fine. Again, assuming that there is no exception, boys have got somewhat higher weight, girls have got somewhat lower weight. But then it is quite possible that some girl may also have higher weight. Suppose this point is here, means the weight of a girl is higher than some boy, but still between these 2 points I can draw this line. So the line need not be always horizontal or vertical like this. Horizontal or vertical like this. It can be oblique also. The only requirement is that it should exactly separate the two classes, girls and boys. So for one parameter h, I have got one axis. X-axis is common for their names. For weight, I have got another axis. Now I go to this example. Now names are removed. Names are removed. You have on x-axis weight and you have on y-axis height. Now what do you observe? Names are not there. Though I have written it for information, this D person might be a boy. Okay, this has got weight something like weight up to say 100 or so, and height might be 5 feet 11 inches. Okay, this girl E, A, B, C, D, E, after E say G, G, she has got weight say 60, height might be 5.2. Fine. Now if I wipe off all those names A, B, C, D, E, F, G, H, now using these two parameters, I should be able to classify I will have to find out equation of a line which will exactly separate the group of boys and group of girls. That is again a learning. Finding out equation of this line is now a learning. Now note that if there are exceptions, then what will happen? The classification boundary may not remain a straight line. Okay, so the classification boundary might be something like this. It may not remain a straight line. Finding out the equation of that curved boundary, okay, that is again a learning. Suppose temperature. For temperature, we say that this is cold country, this is hot country. India comes in, say, hot country. Using a single line, I will plot temperature. Using a single line, I can bifurcate. On left side, there will be cold countries. On right side, there will be hot countries. Very simple classifier. But if you take two parameters, classifier becomes complex. Okay, you are taking two parameters, so there are two axes. And then what has happened here? Now see here, these names E, C, D, B, I, F, G, whatever, each of them, they have become a point in the space. You see there, that point D, he has become a point in the space. I have taken only two parameters, height and weight. Can I take third parameter IQ? If I take third parameter IQ, I will have to take third axis, height, weight, and IQ. Now you can imagine, on the basis of height, you can say that if height is more, he is a girl. If uh, height is more, he will be a most probably. If weight is more, again most probably he is a boy. You cannot comment like IQ in terms of IQ. IQ can be overlapping. Now in this space, your classification boundary may not remain a straight line. It may become a curve. The spaces in which you can separate the pattern using a straight line, they are called as linear spaces. Okay, or linear classification boundary. And applications in which you cannot classify using a single straight line, that is called as non-linear classification boundaries. Linear applications are simpler, non-linear applications are complex or difficult. You already know this. Even in mathematics also we have called this. Now, finding out equation of a line, you require only M and C. M only two parameters. Okay, or if I write it in a slightly different form, y is equal to, I can write instead of m, I write a parameter, say a multiplied by x plus b. Right? This is also equation. I can write capital B here, so that capital characters indicate constants and small characters indicate variables. Now I want to have a line in two-dimensional space. What I will have to do? This equation I can again rewrite. Instead of this y, I can write, say, I will write b here and c here. Right? Is there any change? No. Instead of 1, I am writing some coordinate here. If I want it y is equal to mx plus c, I will have to divide by b. I will get y is equal to a by b plus c by b, where m is equal to a by b and the old y-intercept will be now c by b. I write in different form like this: ax plus by plus c. This can be minus also, but it is a constant. Okay, now this new b, consider that it is equal to minus b. What is this? This is called as linear combination of parameters because it represents a straight line. Line between how many variables? X and y. One dependent, one independent. The space is two-dimensional. Space was two-dimensional. If I take third parameter IQ, then I will have to take third axis. If I take third axis, what will happen? In that case, this might be ax plus by plus cz plus d. This is equation of line in 3D space. क्या कर रहा हूं मैं? I am adding only this term. Now this new D will become C here. Fine. Is it clear? Finding out this A, B, C, D. In fact, we have already studied for 2 dimensions. In numerical mathematics paper, we might have studied something called as linear interpolation. You might have at least heard the term linear interpolation. Finding out these parameters is not linear interpolation. That is nothing but the process of learning. For 3 dimensions, this will happen. Though we call it plane. 3D mathematics we have studied, we call this plane. What will happen if I have got 100 parameters? 100 हो सकता है, एक पर्सन के कैरेक्टरिस्टिक हो सकते हैं, वेट हो सकता है, IQ हो सकता है, स्किन कलर हो सकता है, मेनी अदर पैरामीटर्स हो सकता है, EQ हो सकता है. If there are 100 parameters, then what will happen? What will happen? AX plus BY dash 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 might be some 100 parameters. Suppose some sigma variable might be zeta, fine, plus some constant might be alpha. Okay, this is also equation of line, but how many dimensional space? Might be 100 dimensional space. There are applications where can be 2000 variables. Atmospheric estimations, they can have large number of parameters. Stock markets, they can have large number of parameters. When they predict that it is going to rain and then it doesn't rain, we laugh at them. We laugh at them. But you know, the problem is very difficult to estimate. Laughing at others is always easy. Okay? What happens if one of these parameters is missed? Your application will go wrong. Result will go wrong. Okay? So you have to have large number of parameters in real life. When I talk about 1000 parameters, people start thinking that, oh, that equation is going to be very complex. Let me tell you, it is not complex, it is lengthy. It will become complex. Still, it is a straight line or plane, whatever. If it is 100 dimensional, we call it hyperplane. Up to 3 dimension, we call it plane. Beyond that, we call it hyperplane. Many of you might have studied this terminology while studying fuzzy logic, neural networks, and so on. And such spaces which have got 100 dimensions or anything beyond 3, they are called hyper. Because up to 3 dimensions, you can plot paper on the computer screen. Beyond 3 dimensions, you cannot plot on paper. The reason is that all these axes, they have to be at 90 degrees or orthogonal to each other. So fourth axis in 3D space, you cannot draw. That's why all those spaces beyond 4 dimension, fourth and beyond, they are called as hyperspaces. The straight line will be called as hyperplane. Okay, so still this is simple because this is still linear. Okay, what will happen if it is second order? Here it will be AX plus BX square. Got it? BY plus might be CY square. DY plus EY square. Second order everything. Okay, if it is third order, then a term of X square, term of X cube. Third order, again y square, y cube. All these things for every variable. So if there are 100 variables, there will be 300 terms plus one constant at the end that will represent the intercept or whatsoever. Are you getting it? And then in learning, what you have to do, you have to calculate all these constants. Okay, that is what is learning in neural networks or fuzzy logic systems. Is it clear? Now, as far as our further discussion is concerned, we are going to keep our discussion simpler. So we'll be discussing only related to linear systems. Examples I will give you about different systems. Can somebody please read there? Achha. So n-dimensional feature spaces. I have told you what is n-dimensional feature spaces. If there are 2 features, 2 dimensional, 3 features, 3 dimensions, N dimension is a general term to describe large number of features. Okay, go to presentation mode. Click here. This I have already discussed. Go ahead, please. Go ahead. Now close this. I hope how many of you know convolution? What is convolution? Why to have convolution? Hmm? You can close down this presentation and come back. In fact, these things I have designed all for a big course of around 40-45 lectures for on deep learning. Okay. Now this you come to deep concepting deep learning. So this one might be. Go back. Just wait. Just wait. I'll try to do it from here. Okay. Now you can go to presentation mode. Now see here, a linear classifier we have talked about this. What will be equation of line in 3D space? This one, as I have told you, ax plus by plus cz is equal to d. D might be positive or negative, that doesn't matter much. Okay, computer can handle both the numbers. Then for n dimensional space, what will be your equation? Like this, ax plus by plus cz plus dash 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 nn equal to a constant m, where all capitals are constants and small letters represent the feature axis or variables. Fine. Now what we do is, by this m, we divide to this complete equation. What will I get? Ax by m plus by m plus cz by m. Can you read this? Okay, nn by m is equal to 1. Now this 1 I take on this side, left hand side. So this will become -1 like this, and the equation will become like this. If this equation, this is -1, if this is greater than 0, the value of x, y, z, n will be given to you, just like a point was given on the line. If you substitute in this equation, and if the value you are getting is greater than 0, then what will happen? That point given, it is above the classification boundary. Then same equation, if it is less than 0, then it is below the boundary. And if it is equal to 0, it means it lies on the boundary. Fine. Now what we do is, instead of having these numbers a by m, b by m, c by m and so on, we write some simpler values. Because you know, if I talk about ABCD, what does it indirectly mean? Indirectly means there is nothing more than 26, because we can have only up to 26. So there will be 26 constant, 26 parameters. What will happen if there are 1000? Alpha, beta, gamma also won't be sufficient. So what you have to do is, you use such kind of parameters. So for constants, I am using C1, C2, C3. I can write C1 lakh. That will be 1 lakh constant. Fine. And instead of variable x, y, z, I will write x1, x2, x3. I can write x1 lakh. Fine. So how will be the equation of line then? It was ax plus by plus cz. Instead of that, it will be c1 x1 plus c2 x2. This is not x21, this is x2. By typing mistake, it has gone like that. C3 x3 plus dash 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 cn xn is equal to 1. This is called as a linear combination. You can also write it like this. Summation ck xk, k is equal to 1 to n. Fine. And that is equal to 1. This one anytime you can take on this side like this. Sigma ck xk minus 1 is equal to 0. This equation you have also studied in your DSP, digital signal processing. You call it a linear filter. If you remember, you call it a linear filter, and you say that these are filter coefficients. And those, what are those filter coefficients? They are constant numbers. आपने FIR filter design, IIR filter design अगर DSP पढ़ा है तो computer science might not have studied DSP. Okay, so filter is anything. Filter is anything. For those who are from computer science background, filter is anything which maintains wanted and removes unwanted. Okay, so there is an electronic signal. In that there might be wanted information, unwanted noise, When you apply a filter, unwanted noise will be removed and wanted information will be maintained. That is what is the concept of filter. So this is done using this kind of linear principle. There can be non-linear also. If it is non-linear, then here sigma xk is there, ck xk is there. If it is second order, then there will be another sigma with some dk yk or dk xk square. There will be another summation corresponding to x square. If it is third order, there will be again third summation corresponding to x cube, and this minus 1 will be there. Okay. And what is the gist of the story? Gist of the story is that every entity, just like that boy and girl, they were becoming a point in the space, two-dimensional space. Now, if all of us, we have 100 characteristics, might be having 1000. If I take biometric parameters, biological parameters, hemoglobin, might be sugar. Okay. So what will happen? Biomedical parameters, there are 2000 known parameters. Unknown how many? Nobody knows. Research has not yet reached that level. They can be 1 lakh, 2 lakh, 10 lakh also. And then everybody's some biomedical parameter will be different. Might be your retinal identification number, fingerprint. As you know, everybody has got different. If you take all those parameters, might be 1 lakh, 2 lakh parameters. And all of us, they are a point in the space. All of us, they are point in this huge space of might be 1 lakh, 2 lakh, 10 lakh parameters. How much? We do not know. This exactly matches with our religious preaching also. We are nothing. We are only a small point in the huge space. How big that space is, nobody knows. How much portion you occupy in that space, nobody knows. Okay. So anyway, now this particular equation, I hope this equation, how it came by these proceedings, you have understood it. We have derived it from equation of simple line y is equal to mx plus c by changing the parameters and increasing the number of constants and variables. Fine. Now this thing I can write in the form of a matrix like this. First matrix is C1, C2, C3, Cn and minus 1 like this. Second matrix is variable x1, x2, x3 dash 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 xn. Okay. And here I write 1. When I multiply two matrices, you already know this transpose means it will be a vector. This will be a list, row matrix and column matrix. When you multiply two matrices, what happens? Row of the first matrix multiplied by column of the second matrix. You will get the same thing exactly whatever was here. C1 x1 C plus multiplied by C2 x2 plus C3 x3 dash 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 Cn xn, and minus 1 multiplied by 1 is minus 1 like this and is equal to 0. This particular equation is called as basic learning equation. Okay. Initially, we will be given data x1, x2, x3, xn. Okay. Large number of points will be given to me. Just like for one line, you require 2 points because it is a simple classification boundary. Linear. You require only 2 parameters, m and c. If there is a complex system, you may require more parameters. Second order, third order, 100th order, you may require 101 parameters. In general, as you can see, if there are 100 variables like x, y, z, there are 100 variables, there will be 100 constants plus one constant as a y-intercept. Okay. So if there are 100 variables, parameters will be 101. If there are 1 lakh parameters, 1 lakh variables, parameters will be 1 lakh and 1. Okay. One parameter will be extra, and computing value of those parameters is nothing but learning. So we'll be first given the data that this particular person say is in this class, that particular person is in that class. This type of readily available data is called as supervised learning. Process of learning is called as supervised learning because some data is given and its probable output is given. Such set is given, there is historical data available on the basis of which you learn. Okay. So this is called as supervised learning. Okay. Many times it is unsupervised learning. Supervised learning and unsupervised learning, there are many examples. Supervised learning means what? Teacher will tell the student this is A and this is B. Okay. But in real life learning, what happens? Many times we see unknown parameters and then we remember, I have seen this person at railway station. Do not know the name. From where he is, I do not know. But still I remember that I have seen him at this place. Okay. If the sky is cloudy, even if you do not tell, nobody tells you that if the sky is cloudy, it will rain. After 10-15 experiences and your observations, you come to conclusion that where is cloudy, many times it rains. All the time it may not. All the time it may not. This is unsupervised learning. Without any external guidance, you learn. Okay, what is what you learn? That is what is unsupervised learning. And supervised learning, teacher has to tell you this is A and this is B, then you learn. Both have their own importance, and you can automatically judge the advantages and disadvantages of them. You might have solved this question also in your answered this question also in your neural network paper. What are the advantages and disadvantages of supervised learning? So what will be the first advantage of supervised learning? Can you guess? सुपरवाइज लर्निंग का पहला एडवांटेज क्या हो सकता है? इट इज फास्ट. It is fast. Somebody has told you, no? This is A, this is B. Your learning is fast. Okay? हम लोग बोलते हैं ना इन जनरल भी, दो कलीग्स डिस्कस करते हैं, अरे यार ये सब्जेक्ट मैं फर्स्ट टाइम पढ़ा रहा हूँ, मुझे मुश्किल जा रहा है, आपने ये पहले ही पढ़ा है, मुझे ये बता सकते हो क्या? क्यों बोलते? सुपरवाइज लर्निंग. इट इज फास्ट. ओके. It can learn more accurately because exact data is available for you, some guidance is available for you to learn. What is the disadvantage? Disadvantage is without that teacher you cannot learn. No learning without teacher. In case of unsupervised learning, the first and biggest advantage is it learns without the teacher. Whatever is random data available in front of your eyes, you learn out of that. You learn out of your own experiences. Okay. And then the system becomes ready for application. So the disadvantage is it is slow. आपको अगर खुद के एक्सपीरियंसेस सीखना है तो मेनी टाइम्स क्या होगा? देयर विल बी डैमेज, देयर विल बी लॉस, यू विल हैव टू पे द कॉस्ट लर्निंग. Cost, I am not saying in terms of rupees or this thing. Cost of learning means cost of failures, and after that failure you learn, isn't it? Many times we tell our friend, don't put money in Bitcoin. He doesn't listen to you. Don't put your money in share market. He doesn't listen to you. He invests, share goes down, he loses some 2, 5, 6 lakhs rupees, and without telling you, he then corrects himself. Share market is not for me, isn't it? This is what is unsupervised. You learn out of your own experiences, the data gained on your own. As far as this discussion is concerned, I am keeping it limited to supervised learning initially. Unsupervised also similar principles are available. Okay. So what is in brief learning? In brief learning is nothing but finding out this C1, C2, C3, Cn. If you find out constant like M and C, you will be able to get that boundary. And if you get that boundary, at least you are able to solve a two-class problem. Two-class means what? Above the boundary and below the boundary. Same thing I have drawn, same equation. You see here, K is equal to 1 to N. In case of Ck, I am now calling it weight. In case of constant Ck, I am calling it weight. Wk xk minus 1 is equal to 0. I have implemented it here in this diagram, same equation. Such thing you have done in your control systems. There is input, there is path gain, Okay, there is a summation and there is a bias. Why this bias is there? Because in real life always bias is there, isn't it? Nobody is unbiased. When we teach our 100 students, unintentionally we like a particular student and we start thinking that he is brilliant. And then in the examination, even if something small is wrong, we do not deduct the marks. To be impartial, we cannot give extra marks. But if something is correct and little mistake is there, we do not deduct the mark. This is what is bias. Transistor, electronics people, they will understand. Transistor, or even in 12th standard, you also might have studied the transistor. You call it bias. Bias voltage देते हैं ना ट्रांजिस्टर को वर्क कराने के लिए. Without that, it doesn't work. Now see the two examples. On one side, we say that bias is bad. Bias should not be there. Teacher should not be biased. लेकिन जब तक bias देते नहीं है, ट्रांजिस्टर वर्क भी नहीं करता है. Okay? Indirectly, we all are biased. I am biased. You are biased. What is bias? Our salary is biased, isn't it? If I am not getting salary, why I will go to VNIT and teach there? For making me work, salary is required. If salary is not enough, why you will work? It need not be, I mean, on very high side, but for making you work, just like we say, transistor requires minimum 0.6 volts. 0.7 रहा तो भी कुछ फर्क नहीं पड़ेगा, वो work करेगा. It should not be very saturated also. I have earned crores of rupees, now I need not work. That also is an extreme. If it is too high, then also the system will not work. So it has to be in between. Fine. So anyway, now this is nothing but implementation of the same equation. And many of you might have so far already noted that this is nothing but your basic neural network. This is nothing but your basic neural network. If the output, this output is greater than, O output is greater than 0, the pattern will lie above the line. If it is less than 0 means negative, it will be below the line, and if it's 0 means it is on the boundary. So this works as a two-class classifier. Okay. So from where did we start? We started from our sixth standard equation of line y is equal to mx plus c. You might have studied it in your fifth, sixth standard. And where did we reach? We reached at a basic neural network. Okay. This is called as linear perceptron, basic linear perceptron. We reached at a level which we studied at, might be BTech final year or MTech first year. Neural network, when did you study? I do not know. Those whoever has studied, might be third year computer people might have studied it at third year or final year level. Many electronics, I myself studied it at MTech level. Okay. So this concept is nothing but the concept of extension of concept of a line. Y is equal to mx plus c, which we studied in fifth standard. Not at all difficult. Okay. We studied it from a different perspective. Okay. Then now this bias also I consider as an input. So bias was earlier -1. So -1 divided by this W0. I want to consider bias also as input. So it also has to have some weight. So that weight is W0. So I make it -1 by W0 multiplied by W0. So what it will be? It will be -1. I want to keep it -1. Taken from right hand side to left hand side. That was -1. So same thing again. This is also the same thing. Now here I want to have only one output. In real life, one output is sufficient for classifying two things. Yes or no? Above the line, below the line. Fine. In real life applications, only these two classes will not be enough. Whether it is 100 rupees note, 500 rupees note, 2000 rupees note, 20 rupees note, corresponding to every output, there will be one such O. Okay. The characteristic will be in the input. X1, X2, Xn, what are they? Height, weight, IQ, EQ, whatever. For that particular application, I am telling you. Okay. So what is there at the input? At the input, there are features. Height, weight, they are features. Okay. Might be skin color, EQ, IQ, and so on. Hemoglobin, this, that. might be input features. There will be these weights. Corresponding to every output, there will be one such node. In that case, you get a multi-class classifier or multi-class perceptron. Fine. Then, okay, now we have reached the level of training. I think we should take a break here. So, what is the conclusion? Why do we need a break? Learning is difficult also. Okay, it cannot be done in continuation. Those who have written programs for neural networks, they might be knowing when you program and run it on the machine, it gets trapped in something called as local minima. Okay, you have to break training, you have to give additional input, take tea or coffee, then it will come out of local minima and again it will start learning. Fine. So let us take a break here for 5-10 minutes, and then again, issue is why I am teaching all these things. I am teaching all these things because they are unavoidable part of deep learning neural networks. Fine. And without understanding this, you cannot directly go for deep learning. Okay. Huh. Hmm. You can get up, need not wait for me. इकडे कुठे चाललो आपण? इकडेच आहे ना? पीची अरेंजमेंट इकडेच आहे ना? पीची अरेंजमेंट इकडेच आहे. ठीक आहे, चला पार्टिसिपेंट जसं एवढं काही सेपरेशन मेंटेन करायची गरज आहे. त्यांच्यासाठी नाही आहे का ती? त्यांच्यासाठी नाही आहे का ती?
नाही, त्यांच्याकरता नाही.
अच्छा.
पण मॉर्निंगला झालंय, आता लंच ब्रेक होईल.
ओके. ओके.
एकदम छान फ्लो होता. तसं तुमचं आम्ही एमटेकला ऐकलेलं आहे त्या 5-5 तास.
हा,
तसं ऐकायचं.